Morning, students. Here we go. 10.3 lesson. No big fancy introduction. Let's get right into it. So, basically, we have been studying different types of probability the last couple sections. And really, in the beginning, it was a lot about familiarity with the actual language, like favorable outcomes, what you want, and then outcomes, which is basically the total possible that can happen in any of these probability type situations. So what we're going to focus on today for 10.3 is expand that. We're going to continue discussing probability, but we're going to split it up into calculating two different types: experimental probability and theoretical probability. And in front of you, you should see the key ideas related to both. The difference between both is that in experimental probability, it's probability that is calculated from when you actually do something, just like the word experiment implies. Many of you have done it in science or another different type of class. But it means it's probability that is calculated from actual trials, things that happen. You flip a coin a bunch of times, here's what actually happened. Theoretical probability is that if all possible outcomes are equally likely, so there's an equal chance to get whatever outcome, the theoretical probability is basically the favorable over the number possible, and it's kind of like a perfect system, okay? In the sense that everything's equally likely. This is if you rolled a coin, that's horrible, flipped a coin infinitely times, you would expect that heads would come up 50% of the time, 1 out of 2, theoretically. But in an experiment, you might flip it, and say you flip it 10 times and it came out 6 of the times. Well, that's 6 out of 10, which is greater than 50%. So the difference between experimental and theoretical is that experimental can deviate from what a theoretical probability should happen. Okay? So with that being said, there's not too much of a difference in how you calculate the probabilities. It's still going to be favorable over total. But let's go to these examples right here to kind of see how we can apply it. Okay? So the first set that I have here is a difference between experimental and theoretical, once again. But we're going to go ahead and see how we can calculate the probabilities based on what is given to us. So it says here, it rains 2 out of the last 12 days in March. If this trend continues, how many rainy days would you expect in April? This is definitely a situation where we're talking about experimental probability, because we calculated that it rained 2 out of the last 12 days. So if the trend continues, and this may not come true, but if the experiment continues, how much would you expect in April? Well, the probability of rain is, now I'm using that notation again, P, which is probability, is equal to 2 out of 12, which is 1/6. Reduce it properly. So that means it's a 1 out of 6 probability that it's going to rain. In April, there's 30 days, so the probability of rain in April would be the probability 1/6 times the number of days. And if we do that properly, 1/6 times 30, we're talking 5 days. So using this experimental data, we can say that we would expect that it would rain 5 days in April based on the probability of 1/6 of March. Okay? So that's experimental probability. We got data from something. So let's look at theoretical. So theoretical, okay, it says you randomly choose one of the letters shown. What is theoretical probability of choosing a vowel? So let me change this. You randomly choose one of the letters in the alphabet. Okay, I should make that a little clearer. So what is the theoretical probability of choosing a vowel? So this is all letters from A to Z are equally likely to be chosen. So that means that there are 20, if I'm going to go P of vowel, there are 26 total possibilities. And for favorable, we would use the list A, E, I, O, and U. I'm not going to include Y, contrary to what you guys often hear in language arts. So this would be 5. So what is the theoretical probability of choosing vowel? It'd be 5 out of 26. So theoretically, this is what happens. If I conducted an experiment and I put all the letters inside a bag and I kept pulling them out, that experimental probability could change it. But in an infinite type of system where we did this infinitely times, it would be 5 out of 26. All right, so at this point, hopefully that clarifies a little bit about the differences between both types. The actual calculations don't really change. It's still going to be favorable over total, but it's how you interpret the results or look at the results. All right, so take a moment to pause this video as needed. All right, let's roll to example 2. Okay, so example 2, we're going to take a little bit more robust system. This is one of those classic ABC multiple part questions, and this definitely looks like an experiment. Okay, we're going to roll a number cube, and based on the number, the times that were rolled, it's giving us some data on what numbers came up, 1 through 6. We know that in a theoretical situation, each number would have 1 out of 6. Okay, in probability of coming up. But let's check out how this experiment actually came to be. What is the experimental probability of rolling an odd number? So I'm looking at this and I'm thinking, okay, so for P of odd, my favorable is going to be 1, 3, and 5. And looking at that, I have 48 times it came up for 1, it came up 50 times for 3, and it came 49 times for 5. So if they rolled it 300 times, that's the total possible. But for this situation, okay, the experiment showed that it actually came out 147 out of 300. So the experimental probability would be 147 over 300 out of 300. And reducing that, it comes out to be 49 out of 100. Okay, so always reduce as needed. So really, once we understand and establish that it's an experimental probability, all we have to do is count up, total up our favorable outcomes. It doesn't change how actual probability is calculated. All right, let's look at the next one. How does the experimental probability compare with the theoretical probability of rolling an odd number? So in this case, what we got to be thinking is, okay, theoretically, if you roll it 300 times, that means each number should have the same equally likely ability to come up. Okay, wow, that was a little tongue twister. But basically, if each number has the same chance of coming up, then that means 1, 3, and 5 are half of the numbers on a standard rolling dice. We would expect it to come out 150 out of 300, or 1/2, because that would be the theoretically it should come up half the time, an odd number, because there are half the numbers, half of them are favorable in a 6-sided dice. Now in our experiment, it only came up 147. That's okay. So the probability of getting an odd in our experiment was a little bit lower than the theoretical, but they should be fairly close in most situations. Okay. Last but not least, let's look at C. Compare the experimental probability in part A to the experimental probability in example 1. Actually, we just talked about that in part B. The experimental probability is a little bit lower. It's not a whole lot lower. We would definitely want to analyze the experiment if it was like drastically lower. We would expect odd numbers or even numbers to come up half the time. If it was drastically low, then we got to be thinking certain variables could have happened to go ahead and cause that experiment to be a little bit less reliable. Could have been inconsistent style of rolling, the weight of the dice might not be accurate, a whole bunch of different variables. But basically, okay, what you should see here are how to calculate both types and apply it. With that being said, that is the end of the examples for this section. Okay, I'm going to go ahead and roll over to, or scroll to, the OYO section. I'm going to let the video roll for about 10 seconds, and then the answer key will pop up here on the board. Okay, go ahead and give these a try. All right, students, so the answer key should pop up, and if these went pretty quick for you, that's a good thing. They shouldn't really take much longer than just a few for each question. So for the first one, we have a situation where we did an experimental situation where we flipped sticks that had red and blue, and these were the outcomes. There were 10 favorable, I apologize for that, 10 total possibilities. That's why in all of these probabilities, 10 is going to be in the denominator. And then for 1, 2, and 3, you just had to look at the frequency and look it up on the table. The only tricky one would probably be number 3, where it's talking about not tossing all blue. So there were 2 times where 3 blue came up. The rest of the situations are favorable, so it'd be 8 out of 10. And then number 4 is a theoretical probability. If we spun this infinitely times, we would expect the purple to come up 1 out of 6 times because there are 6 specific spots. Even though there's that double red, that does not change our probability for purple. All right, with that being said, all right, that does conclude this lesson. Feel free to review it. In Big Ideas Math Online, you should have a couple sets of questions to go over. Okay, reach out to me if you have any questions. All right, thanks for watching.